Hello and welcome to a new video. This is for Algebra 1. It's a review of Units 3 and 4, which is, Unit 3 was writing linear equations, and Unit 4 is all about linear inequalities. So it's going to be a review of those things, so here we go. Write the slope-intercept form of the equation of each line given, and the slope and the y-intercept. So we have slope -1, y-intercept -2. Remember that slope-intercept form is y equals mx plus b, where slope is m and the y-intercept is b, and so that means that this would be y equals -1x minus 2, or even better would be to say just -x and then minus 2, but I think most, if not everyone, would accept the -1 being in front of x. We just don't need that 1 written there if we realize it. All right, now we've got 4 of these graphs because there's different things about each one that we want to notice. So on 2, slope-intercept form, we need to pick out the y-intercept, which is right here. That would be 1, so b is 1. The slope, we can use the y-intercept, and then we need to pick another nice point. So see how, like, here it doesn't go through the grid line, so we wouldn't want to pick that point. It looks like we need to pick this point right here, or on the other side, this point, whatever. Just pick 2 points that work. So we need to count the rise over the run. So we need to go up 3. Because think of this like we've got like perpendicular streets or something. We need to go up 3 over 4, so our slope is 3/4. So slope-intercept form would be y equals 3/4 x plus 1. That'd be our answer. Now on 3, vertical lines are special, and so the easiest thing to do is to memorize them for their specialness. So there's a trick with thinking about the slope. This is an undefined line, or an undefined slope, because a skier on this line would have an undefined amount of fun, because they go really, really fast forever and ever and ever, which is in comparison to on 4, where we've got a skier that would have 0 fun because they're having to push themselves the whole time. So an undefined slope is x equals whatever number this is going through. The other way to think about it is to say, okay, what do all these points have in common on this line? They all have the same x value. So they all have an x value of 5. This equation would have to be x equals 5. Because y can be whatever it wants, and is whatever it wants, but x has to be 5 based on this vertical line. So the easiest thing to do probably is to say, I'm just going to memorize vertical lines are x equals, vertical lines are x equals, vertical lines are x equals. And it might help if you think of it as being opposite in some ways, because the x-axis, right, goes this way, right, which is horizontal, but our x equals 5 line is vertical, so it might feel kind of backwards because of that situation. 4, we've got a horizontal line, 0 slope, and so you can use just normal slope-intercept form on this, because the slope is 0. We'd rise nothing and run, so that gives us 0, and our y-intercept is -5. So we can actually fill in y equals 0x minus 5, and well, 0x we don't need because that would just be 0, so that'd be y equals -5. That'd be our answer. Let's look at 5. So we need our y-intercept, which is up here at 3, and then we need to pick another point so we can see the slope. Looks like this is one that has lots of points that work. This is down 1, right 1, and so our slope should be -1 over 1, which is just -1. So that's y equals -x plus 3. If any of these things are tripping you up, by the way, I have videos on each thing in particular, so you can go back and I'll link the playlist for Algebra 1, but you can go back, like this would be in 3.1, I believe, that video, so it would give you kind of more practice and things like that you could look at if this is giving you some trouble. And overall, for like 2 and 5, where we've got diagonal lines, up and right is positive, and we ended up with positive 3/4. Down and right is negative, and so that's how we ended up with a -1 for our slope. that can be something else that can help you just kind of double check that you have the right numbers. All right, write the slope-intercept form of the equation of the line through the given point with the given slope. So now we are writing in slope-intercept form, which is y equals mx plus b, and we know the slope, which is m, but we are not told b. We are, however, given an x and a y. So what we do is we fill this into y equals mx plus b and solve for b. So we put a -4 where y is. We put -1/3 where m is. We put 3 where x is. And then we leave plus b as plus b because that's what we're trying to find. So -1/3 times 3 over 1, the 3's cancel, and we'd have -1 times 1, which is -1. And so then we'll add 1 to both sides and get -3 equals b. So we end up writing this as y equals mx plus b with m, which they gave us, and b, which we found. So our answer here is y equals -1/3 x minus 3. Now we actually learned how to write equations two different ways. We also learned how to write it in point slope. This specifies that it wants you to answer in slope-intercept form, so one could argue that writing it in point slope would not be the correct answer. This is one of those times that can be frustrating. I'll admit that with you. It can be frustrating when that happens because you might feel like, well, it's the same thing. Why do I have to write it a certain way? Well, at this point in math, there are usually different ways to do things, and sometimes it's okay to sometimes we just let you pick which way you want to do it, but other times we want to test to see that you understand how to do each way. If you did it in point slope, though, you could change it to slope-intercept form pretty easily by distributing and things like that. So keep that in mind. Okay, on this next one, -3, 3, and -2 for our slope. I'm going to plug all this in to find b. So this would be y equals m times x plus b. And as I say those letters, I'm filling it in with the given information. So -2 times -3 is a positive 6. We're going to subtract 6 from both sides. I did not want to put that line there. That makes it look like I'm dividing, but I'm not. I'm subtracting. I was about to get real thrown off there myself. So 3 minus 6 is -3. Oh, that's awkward. These had the same y-intercept. Whoops. Y equals -2x minus 3 is our answer. This one says, write the point slope form of the equation of the line through the given point with the given slope. So point slope is the one that looks a little bit more intimidating, but is actually easier to use. And I'm writing it up here at the top. It kind of looks, I think, more intimidating because we have y and y1, x and x1. But what happens is, instead of labeling the point they gave us as x and y, we label it as x1 and y1, which I know that's a little weird. So we're saying, hey, this is a point they gave us, point number 1. We label the slope as m, and then we fill it in up here, and then we get to just leave it because it just says write it in point slope form. So that's the nice part about it. So let's see. Y minus -4 equals m, which is 7/2, and then x minus -2. Now I wrote this out minus -4 and minus -2. We would want to switch those because two negatives next to each other make a positive. So we'd want to switch this to y plus 4 equals 7/2 x plus 2. That would be our answer. And you could skip that step in the middle if you want to. If you're like, oh, I know that minusing a negative changes it to plus. Absolutely, you can write that way first, and that's fine with me. Let's look at 9. So this is x1, y1, and m. So y minus 5. That one we won't need to change because it's not a double negative situation. Equals -8 times x. This one is minus -1, so we'll switch that to plus 1. There's this thing called the Super Secret Opposite Society, which is super secret, so don't tell anybody about it. But anytime we have parentheses in math, we end up with this thing where things become opposite. So in the parentheses with x plus 1, right, we originally had -1, but we put it in parentheses, so now it's plus 1. And if you're like, well, y minus 5 isn't in parentheses, we could put it in parentheses, and it would be part of that society as well. It's a bit of a stretch on this. There are a lot of things in math that do work with the secret opposite society, so that's why I brought it up, because when we do things later this year, I'll bring it up again. Don't you worry, it'll happen. Now this section says just to write the equation on the line through the given points. You can choose which form to write it in. So this is where if you've got a preference between slope-intercept form and point-slope form, then you should do which one you feel more comfortable with. This is also, though, a section where we might end up with our vertical or horizontal lines. And so let's actually kind of glance through and see if we can pick those out. Vertical lines are x equals something, and so in order for it to be a vertical line, our points have to have the same x value. Horizontal lines are y equals, so they have to have the same y value. So just glancing through the points, do you see a situation where both points have the same x or both points have the same y? And I see both of those situations. So on 10, both of these have the same x. X is 1 here, x is 1 here. That means x has to be 1. And so I don't even have to do any work for that. I just say, okay, they're both 1. It has to be x equals 1. There's no situation, unless they gave us the exact same point, which would not be something we could find a line with anyway. But if they're both 1, it has to be x equals 1. Let's look and see if we can find y equals 13, right? 13, oh, and this is also 1. Y equals 1. So then these other two, we're just going to have to kind of decide, do we want to write these in slope-intercept or do we want to write them in point-slope? And it doesn't matter to me which one you choose to do. So I'll actually write the answer 3 different ways, because there's 3 different versions of this that we could have. On both of these, though, we're going to need to find the slope. And we could have found the slope on 10 and 13 as well. But the slope formula is subtract your y's on top and subtract your y's on top and subtract your x's on bottom. Not really sure what's going on with me writing there. Okay, so we label our points x1, y1, x2, y2, and then we can fill this into our slope formula. So that would be -3 minus -4 on top and 2 minus 0 on bottom. Well, minusing a negative is the same as adding. So -3 plus 4 is 1. 2 minus 0 is 2. So our slope is a half. Now, if we realize it, this is actually telling us the y-intercept, because when x is 0, that's telling us that our y-intercept is -4. So if you realize that, then you can get to the answer just a little bit faster. If we didn't realize that, we could plug it in to find b, just like we did earlier. In slope-intercept form, this one would be y equals 1/2 x minus 4. In point-slope, there's 2 different versions because we have 2 different points. So using the first point, we'd have y plus 4 equals 1/2 x minus 0, which we don't have to have that minus 0. We could just have 1/2 x on the right. And with the second point, we'd get y plus 3 equals 1/2 x minus 2. You would not need to write all 3 of these answers. You just need one of these answers. But those are the only 3 right answers, other than some version of the second one where you don't write the minus 0. So there you go. 12. We need to find the slope. So this is x1, y1, x2, y2. So we'll do -4 minus 3 on top and -4 minus 3 on bottom. I have a feeling I know what's going to happen here. These are both -7, so that gives us a +1. So if you were writing in slope-intercept form, now we'd pick one of the 2 points and plug in to y equals mx plus b. So we could pick 3, 3, just because it's positive is why I would pick that one over the other one. But they'll give you the same thing. I get 3 equals 3 plus b minus 3, and get that b is 0. So in slope-intercept form, this is y equals 1x plus 0, which is just y equals x. If we were doing point slope, it would look like y minus 3 equals 1 times x minus 3, or y plus 4 equals 1 times x plus 4. Again, this is a review, so if you're like, man, I just don't get what you're doing, go back on my channel. This would be some section. You could go back and look at it and remember how to do it in more detail. Right, the equation of the line described, you can choose which form to write it in. So here, we're given a different set of information. We're told about a line parallel on 14 and a line perpendicular, that's what perp stands for, on 15. And so we have to remember something that's true about parallel lines and their slopes. Parallel lines, since they never meet, they have to have the same slope. So if the slope they gave us is -3, and we want a line that's parallel but goes through this point, that means that we also have to be a slope of -3. Then we can choose which way we want to write it. If we want to write it in slope-intercept form, we'd use this point and plug into y equals mx plus b and solve for b. Or we can do point slope, whichever one we prefer. Plus 3, 2 equals b. So y equals -3x plus 2. And then if we wanted to instead write it in point slope, there's only one, I guess, answer for point slope this time because we only have 1 point. It'd be y plus 1 equals -3 and then x minus 1. So one of these two answers is what we would want to have. Perpendicular lines are more complicated. Perpendicular lines are lines that meet at a right angle. And so what's true about their slopes is that they're opposite reciprocals. So if this is 2/5, I didn't really mean to make that mark. If this is 2/5, we need to flip it and make it negative, and that's the slope that we want to use. So our slope should be -5/2. We can either find b to write it in slope-intercept form, or we can write it in point slope, whichever one. So if we're doing it this way, these 2's cancel, and we'd get -5 times 2 is -10, -5. I'm going to add 10 to both sides. So this is b equals 5, and that means I get y equals -5/2 x plus 5. Or in point slope, that would be y plus 5 equals -5/2 x minus 4. Now let's switch gears to linear inequalities. So this is Unit 4. So if you're trying to look back at and find more resources or videos, you'd go back and look at like 4.1 would be the 16 and 17 here. So on 16, we've got x plus 10 is greater than 27. We want to solve for x, so we subtract 10 from both sides. Not a lot of room here. So x is greater than 17. Now that seems like a really big number, but look, our number line has accounted for that. 17 is right here. If it doesn't have a line underneath, you put an open circle on 17, and then we're going to shade greater than 17, which would be the numbers to the right. So that would be this direction right here. 17, when we have a fraction like this, we want to say, well, it's p divided by 5. Let me do the opposite, which is 2 times by 5. So I'm going to cancel out those 5s and get p is less than or equal to -20. When it's equal to like this, we put a filled in circle, so we color in that circle. We want to graph less than, which is numbers to the left. It's weird once we now have, positives and negatives, because when we talk about less than, and we have a negative number, less than means more negative, a bigger negative number. So definitely want to think of less than and greater than now in terms of a number line and thinking about left and right on a number line. 18 and 19 are a little bit more complicated inequalities. Remember, our key thing with inequalities that's different from equations is that if we multiply or divide by a negative number in our efforts to solve, we have to flip the inequality symbol around. So on 18, that's not going to happen, but I just thought I'd mention it. On 18, I have to do just like I would with an equation and add the 10 over first. We always save what's right next to our variable for last, so this 4 I want to take care of after I've moved the negative 10. So on our next step, we'll have n over 4 is greater than or equal to negative 2. Then I want to say, okay, how do I move that 4? I'm going to times by 4 on both sides. So n is greater than or equal to negative 8. So this says solve each inequality and graph its solution. So this inequality that I have now boxed, that is part of our answer, and the graph is part of our answer. So don't be silly and not actually write out the inequality answer, because I mean that's part of the answer. So don't leave that out. If you're doing all this hard work and then you don't even write half the answer, then you'll be sad and I'll be sad and everybody will be sad. Well, let's look at 19. Negative 3a plus 9 is greater than 0. So we save the negative 3 for last because it's right next to a. We start by subtracting 9. 0 minus 9 is negative 9. Now let's divide by negative 3. Since we're dividing by negative 3, we need to, I don't know why I just did that, we need to flip the inequality around. I was about to say it, and then I just wrote the inequality like a silly goose. So, because I divided by a negative 3 instead of a positive 3, in order to solve this, I have to flip it around so that it's less than. Negative 9 divided by negative 3 is a positive 3. So I need to put an open circle, because there's not a line underneath my inequality saying it's equal to. And then I need to shade to the left, like a so. Well, let's maybe make them a little bit more complicated. Now we've got a variable on each side. So the easiest way to graph is to have x be on the left, because then you can use this trick of the inequality like pointing you the direction you want to shade. So even if it's not something you would normally do because of whether you get a positive or negative, these are not great examples of that. We want to move the x or whatever variable to the left. So I want to do minus x over here as opposed to subtracting 4x over to the right, because I want the x to be on the left side. So I get 10 equals 4x minus x is 3x. And then I say, okay, now let me move the 10, and I get 3x is less than or equal to 1 minus 10 would be negative 9. Then I divide both sides by 3. Now, our rule is that we flip the inequality when we divide by a negative. So the fact that negative 9 is negative isn't what matters here, isn't what makes us flip. It would be that the 3 would have to be negative. So this does not flip around. That's an important distinction to make. When I say divide by a negative, that means the bottom number needs to be negative for you to flip the inequality around. So x is less than or equal to negative 3 is my answer. So I'd put a filled in circle at negative 3 and then shade to the left. If you remember, another way to shade is to like shade like below or above the number line so it's more obvious, or you can even put the circle off of the number line and then shade off the number line. If you're like the way I draw on the number line, it isn't super obvious, then that's something you definitely should think about doing. Let's look at 21. So I would subtract 4k over to the left, and that gives me just k, well, 2 plus k. And then I'm going to subtract 2, so k is greater than negative 7 is my answer. And I'm going to, let's see, negative 7 should be between negative 6 and negative 8. It should be an open circle because we're not equal to. I'm going to shade to the left. So that would be an example of how we could shade so that it would be obvious which direction we were shading. Compound inequalities. So compound inequalities are either and inequalities or inequalities, and they either use the word and or, like 23 has the word or they might look like 22 where it's just all written as one inequality. When it's all written as one, like kind of phrase, I guess we would say here, then this has to be an and. You can't write an or combined together like this. So what we do whenever it's together is we say, well, how do I solve this middle? How do I make it so it's just p instead of p plus 1? We'd minus 1. So we have to do that to the left and the right and the middle to keep it an inequality. An even inequality, I don't know. -9 plus -1 is -10, which is less than p, which is less than or equal to -3. Now, this can trip people up because why are these both less thans? Well, if we read it from the perspective of p in the middle, it's saying p is, it's actually saying p is greater than -10 because the open side is towards p. So p is greater than -10 if I look backwards, and p is less than or equal to -3 as I look forward. So essentially we want to shade in between -10 and -3 because that's where p is. At -10 we'd put an open circle because it's not equal to here, and at -3 we'd put a filled in circle because it is. And then in the middle here we would shade in the middle. And if you do shade above or below, it can make it look like a really cool boxy car. Just saying. 23 is or. So and shades in, so shades between, or shades out from the middle, which maybe is unsatisfying, but there you go. So for the first one, -4x is less than -12. We're going to divide both sides by -4. We're going to go, oh, I divided by a negative, so let me flip this and make it greater than. So x is greater than 3, or the second one, we need to subtract 10 from both sides and get x is less than -3. Now, if it helps you to write these the other way, because -3 is to the left of +3, that might help because then it looks more obvious, right, that those inequalities are pointing away from each other, so we should shade out the way it was written the first way. They look like they're pointing towards each other, but the numbers aren't in the right order to kind of use that trick. These are both not equal to, so open circles at -3 and at 3, and we're less than -3, so that's left. We're greater than +3, so that's right. So we shade out. Last section, graphing linear inequalities with two variables. So our first step is to graph the line like normal, taking into account that if it's equal to, it's a normal line. If it's not equal to, we're going to do a dashed or a dotted line. And then we're going to shade either above or below or left or right, depending on what the inequality actually says. So here we graph with the -1 first, put that dot here. And then we go up 1 and right 3 for our slope. Up 1, right 3. Up 1, right 3. And then we draw the line that goes through here. It's a solid line because this has a line underneath it, right, for equal to. So we'll just draw. And then it's less than. So think about this line as having Think about this line as having divided this into two parts, right? And so we could label that like a top part and a bottom part, or top left, bottom right, something like that. We want to pick the values that are less than or equal to for y. Y is less than or equal to 1/3 x minus 1. So we want to shade below the line, which means I'm going to shade down here. Some lines are easier to tell what's above and below than others. So one trick is to think about your y-intercept -1 and say, where are the numbers that are less than -1? That'd be -2 and so on. That can help. I actually like to do that even more visually by saying, put your pin on the line. Since it's less than, draw yourself an arrow down. Whatever side you drew on, that's the direction we should shade. Usually it's the steeper lines that can possibly throw us off, so keep that in mind. 25. This is a vertical line. In my head, as I was thinking about this, I was about to graph a horizontal line. That would not be right. This is a vertical line through -5. That's not equal to, so we're going to make it dotted or dashed. I prefer dashed. I like dashed lines. We want to shade greater than -5. Now, we're divided into like a left and right situation. Where are the numbers for x? That would be bigger than -5. That would be over on this side. This is wonderful looking shading. I actually went over the line a little bit, that's not good. Don't do that. But that would be how we would shade this one. Y is greater than or equal to -1. That would be a horizontal line, solid because of the equal to. So like so. We want to graph greater than, so that's above the line. So like I said, the horizontally, it's not really hard to, if it's a horizontal line, it's not really super hard to tell what's above and below, right? But on 27 here, I think this is going to be steep, so hopefully this shows you what I mean. We're going to start at -1. Our slope is up 6 over 1, so that's here. This is probably, oh, it's dashed. It's probably going to look terrible because I'm not good with steep lines on the computer drawing tablet. So pretend that's a straight line, it's a dashed line, and we want to be greater than this. So we got to think, okay, where are the numbers for y that are greater than this line? So this is where I would put my pen here on -1, just because it's an easy place to put it, and then I would draw an arrow up because it's greater than, and I'd say, okay, this side of the line is where I want to shade. So that would be my answer there. Again, this is a review, so I have videos for each of these in a, like, you know, more explanatory, I don't know if that's a word. I explain more about all of these concepts in the original videos that went over them. So if you're like, man, this just is not making sense, you can go back and find, this would be our 4.4 video on graphing linear inequalities, and hopefully that would help. You also could always leave a comment below if you're struggling on any of these things, and maybe I'll be able to get back to you. Hopefully I'll be able to get back to you on that so I can help you. Hey, thanks for watching. I really appreciate it. I'm one of those people who, you know, like, puts videos on YouTube in the hopes that someday it might make me money. It makes me a little bit of money right now, but you subscribing and you watching and you giving me a thumbs up, all of those things help me, and I'd appreciate it. So if you want to say thank you back, then that's the way to do it, is make sure you're subscribed, put a like on the video, comment if you want to, and then just, you know, go along on your merry business. Maybe check out the next Algebra 1 video I do, which will, you know, be in a week or two probably. So thanks for watching. Bye.